Martin. This is the first unit of 10 in our Chemistry 1 course. It is an introduction to chemistry and scientific ways of thinking. Carl Sagan said, "Somewhere something incredible is waiting to be known." And this certainly is true of science, but it's also true of life. And I think it's a great way in a philosophy to go through life is with a sense of curiosity, a sense of wonder, and an open mind to learn and experience new things. So in this unit, we'll be looking at how scientists think and about how they reason, and a little bit about the branches of science and of chemistry. And we'll be looking at some careers within those branches as well. Definitions, basic definitions. Science is the search for truth. And so in a lot of ways, we are all scientists. We're all out there and we're all seeking the truth. We're trying to figure out the world around us and why things happen the way that they do. And certainly within these branches, you have pure science, which is the focus on just obtaining knowledge for knowledge's sake. Say that you were walking in the woods and you saw moss growing on one particular side of the tree more than others. So you might ask yourself, well, why does that happen? And you'd look at the moss and its makeup and maybe take some pictures and go back and research that and find out what type of organisms makes up that algae. And so that would be an example of just finding out something for the joy of finding it out. And applied science is obtaining information to solve a problem. And so a lot of times we'll be presented with things in our everyday lives that might be a challenge for us. Maybe we're having a hard time adapting to our environment. Maybe we're having a hard time getting to school on time. And so you would go about investigating different ways of getting to school on time. Maybe having an alternative ride source, or maybe asking a friend to come by a little bit earlier. And so you would be trying to solve a specific problem. There are all sorts of examples of this in the sciences. Pure sciences, an example of that would be something like astronomy or chemistry or biology. Those have practical applications, and so you might say, well, you study those to solve problems also. But the pure chemistry, the pure biology, the pure astronomy, finding out just about those sciences and about the world around you aren't designed to solve a certain problem. But in the applied sciences, things like engineering and agriculture would be considered to be applied sciences, because they would be maybe building a building or designing an electrical system or finding a specific crop that would help feed the world. So there are some overlaps in these areas, of course, and once you maybe study something, you find an application for it. And so those things certainly don't in a bubble in and of themselves, they overlap. We talked about biology, the study of living things. And within biology, you have things like microbiology, ecology, so forth. And chemistry, of course, under chemistry, you have all sorts of branches as well. And it's a really big, broad category for both of these sciences, study of matter and the changes it undergoes. And so in chemistry, we talk about organic and inorganic chemistry. We talk about biochemistry, and all those types of things fall under thermodynamics. All sorts of things fall under the branch of chemistry. Astronomy, study of all objects in space. So when we went to the moon, for example, we were studying the moon rocks, the moon environment, all the different things involved in discovering that planet. But we also, technology that we used, we found applications for those elsewhere. And so think about astronomy being a pure science, but certainly when you study these different pure sciences, find all sorts of uses for those and ways to solve problems that man has. Examples of applied science. Agriculture is near and dear to my heart. I worked for 12 years in agricultural research. And so we were very much concerned with our practicing of cultivating of crops and producing crops that would improve the lives of people. Livestock's also a big part of that. I wasn't involved in that myself, but I was involved in producing crops to feed animals and to have those for livestock production. Marketing and economics, ag economics, certainly are important parts of that as well. Making crops profitable for farmers globally. When you look at problems of feeding the world and feeding undeveloped countries, researching better ways of feeding those folks is certainly a challenge. Engineering, application of math and science to solve problems. Have all kinds of different types of engineering, mechanical, electrical, civil engineering, and so even chemical engineering is a branch of chemistry or engineering, which is quite fascinating and a very lucrative job. If you ever have a passion for engineering and also of chemistry, you can put those together and make a really neat career out of it, one that's quite in demand and profitable. Scientific method. Okay, so I'm going to pause here and just talk a little bit about why I think it's so important to talk about the scientific method. The scientific method is something that you study throughout your career in academia, you know, from a very young science student on up through the high school level. And sometimes people kind of leave it when they start talking about big subjects like biology and chemistry and so forth. But the scientific method is very, very important to keep in mind as you're going about your investigations and about your experiments in these sciences. And it's not only important to have a firm grasp of it to be successful in those, but also when you take the ACT or the SAT in college, because sometimes you'll have to evaluate experiments in that section of the test. And if you have a firm grasp of what a good experiment looks like and the thinking and reasoning behind going through a very methodical approach. And you can really use it in your everyday life as well when you're faced with difficult situations. I have a little acronym that helps me remember the steps of the scientific method. It's OC heat or O cheat, and the first one here is observations. So when you go through, and we'll go about each one of these and talk about them individually, but observe things, you collect data, whether it's formal or informal collection of data. You create a hypothesis, which is an educated guess about the problem or a connection with some sort of thing that you're interested in. And you experiment and try to reason and come up with a theory about how things work. So the hypothesis is an initial theory. You experiment and you do data analysis to determine if that idea is valid. Probably one of the most important parts of the scientific method is the first step, which is observation. So as you go through your everyday life, you make observations of things that occur. And in science, a lot of times we'll see something that's super interesting that we observe that we want to study, or we might have a problem that presents itself. And so we observe these phenomenon or events, and we try to take careful notes and try to make sure that we don't lose this opportunity to investigate. So it says here, careful observations must be made. Success is dependent upon staying alert and keeping careful and complete notes. So when I was involved in research, I was involved in soybean research toward the end of my career. And we were walking out in the field for days and days on end looking at soybeans, and there wasn't a whole lot of variety in soybeans that we were observing, but there were some important differences. And so maybe it was disease resistance, maybe it was pod set, or color of the flowers, or the pubescence on the stems and leaves. And so you had to be always constantly alert and able to pick up on the phenomenon that was happening around you. And so this first step is super important, and it all goes back to when we were talking first about being open to learning new things and to having an inquisitive mind. The next part is collection of data, and data can be qualitative or quantitative. And when you think about these, think of Quality and quantity. And quality is a little tricky because you can put a quantity to quality as well, but qualitative things are like flower color, maybe color of a blister or a lesion on the skin, appearance of a gas in a chemical reaction. Those are things that you might think of as a quality type valuation. I used to work at a large commercial bakery, and we were concerned with the flavor of our products. We had rolls and we had bread and sweet goods and all sorts of really great things to taste. And so that is a very quality valuation. But in the same token, we were also interested in the height of the loaves and the appearance of the loaves, and sometimes we gave those numbers, and that would be a quantitative analysis. And so we would measure the height of the loaf, and we call that the kick. And so we would measure that and have a measurement for it. And even sometimes with the taste, although you think of that as a qualitative type of analysis or thing to talk about, you think of that as a qualitative thing. Well, we wanted to put a number to it to get some kind of a scale. And so qualitative things can have a quantitative number associated with them sometimes as well. So they kind of overlap. In agriculture, yield was a big one. We wanted to have as many bushels per acre for our corn and soybeans as possible. In medicine, you might have blood counts, white blood cell counts, red blood cell counts, and so forth, or the weight of the patient. How does that change if they have a particular type of disease or problem? And so qualitative and quantitative analysis, collection of data, and really when you collect data and make observations, it's really important to write things down. As you go about solving problems in your everyday life, you may have had a problem and you're discussing it with a friend or a colleague, and they give you some really good ideas about how to solve that problem. Well, if you don't write them down, in a few hours you may have forgotten. And so taking careful notes is important. And I always say that keeping a journal is a super great way of living your life. A lot of times you'll have a really brilliant idea and then it just escapes you in a few hours or a few minutes. I know that writers, people who write for a living, either maybe they write novels or short stories, or maybe they're involved in journalism, they always keep a writer's notebook so that they can jot down important facts or ideas that they have. So that is a super important part of the scientific method. Next step is hypothesis. And hypothesis is an educated guess, and that's usually how it is framed. But you can also think about it as being a solution to a problem or a cause and effect type of statement. A good hypothesis statement is one that can be proved with data or an experiment. And so an example of a hypothesis is, I think obesity causes heart attacks. And so you would need to go through and either conduct an experiment or look at lots and lots of data of people that are prone to heart ailments or heart attacks. And you could look at the data and see if you can find a correlation between obesity and heart attacks. It can also be kind of seen as a solution to a problem. So another hypothesis statement might be something like, if people follow a healthy diet, they will not have heart attacks. And so you would go about having a control group that you don't control their diet, and then you would have an experimental group where you would maybe have a diet that's low in fat content, for example, or maybe a Mediterranean diet where you eat mainly fish and vegetables and that sort of thing. And so an hypothesis is a testable guess to a problem, or it can also be thought of a cause and effect type of statement where you need to have an experiment to prove in a relationship. Experiments are conducted to prove or disprove a hypothesis. If the hypothesis is proven to be reasonable, further experiments may be needed. Okay, so your experiment may prove or seem to prove your theory, But is it true in all circumstances? Is it true under all conditions? And so we must go back and re-experiment to prove our theory, or to have a better idea, at least, if the theory will hold true. If the hypothesis is proven to be untrue, you must go back and make more observations and then come up with a new theory to test in an experiment. And this is all part of the process. And you know this to be true when you have problems in your own life. You may come up with what you think is a good solution, and then when you actually go to put it into practice, it falls all apart. And so then you got to go back and come up with a new solution or a new hypothesis to help solve your problem. Data analysis. This is really crucial, and to learn more about data and how to look at data is an important part of becoming a good scientist. Sometimes differences just might be due to chance or conditions, so statistical evaluation of data must be taking place. For example, a 4% increase in yield of one soybean variety in experiment may be due to the soil type, moisture levels, and other environmental factors. In another year, the variety might not yield as well. So you have to have multiple years of experiments and under various different conditions to come up with ideas of what's the best soybean variety, and I used to do that in my years in research. Measurements and other observations are evaluated, see if the hypothesis is true. Just because there is a difference in significance doesn't mean necessarily that it is true or significant. Sometimes a 4% increase isn't good enough, in other words, and it might not hold over multiple experiments. So we use statistical tools to determine that, and we'll talk more about that in the next unit. And the all-important theory, if you have multiple years of experiments where it looks like you've got a good grasp and a good hypothesis, you can come up with a scientific theory. So this is over multiple years. Sometimes additional experiments must be conducted to test the theory and may limit the scope of the theory. Just because you have a sound theory over multiple experiments, you might want to test it under different conditions in a different set of variables. Scientific laws come very, very few and far between, because over many, many years there are no known exceptions to the law. Law of gravity, for example, works here on planet Earth. It works out in the universe. Over multiple years of experimentation, the law of gravity holds true. So scientific laws hold an even higher level of proof that's needed for those to hold true. Okay, well done. This is the end of our first recording of the lesson. Thanks for hanging in there with me. And in the next recording, we'll be talking more about the process of being a scientist, writing good experiments, and doing that kind of thing. And I think you'll find it to be very interesting. Thanks again, and hang in there. We're just getting started.